Hi everyone, my name is Gagan. I'm a data engineer. Welcome back to the channel for part 2 of the IPL option project. If you haven't seen the part 1, there's nothing to be worried about because we will cover SQL in this one again. So, what this video is all about, I can tell you what this is not about. So, this is not an introduction to PySpark. There's plenty of good resources out there, so you can find videos on what exactly Spark is, um, how it functions, and what's the utility of it. What we are trying to do is bring a use case of PySpark into data manipulation, so you can see it in practice, how you can actually use it. So let's begin. Best way to yeah, let's just begin. So first thing you want to do is actually install the required packages. So we already have, we might use pandas at some point. I'm not sure, but you don't need to install it. But you do need to install PySpark. So let's install PySpark, um, and it should start installing. It should not take, it shouldn't take much time. So let's see. Till then, I can actually type libraries I will be importing. So pandas is PD. I'm not sure if I'll use it as I mentioned, but you never know. From PySpark .sql import Spark session. And last but not the least, from PySpark.sql import everything. Actually, it's not a good idea to import everything, but usually you import things based on use cases. But since we're just practicing, so yeah, just import everything. Let's see how it goes. So yeah, let me run this. It's installed. It's imported. Next step, downloading dataset, and actually I'm missing one step. Okay, let's do it here. What I want to do is start Spark session. So start Spark session, and how you do it is I'm gonna save it in the variable Spark, and Spark session is basically you just use this Spark session builder and then get or create, and it should work. So one thing that's different from Spark compared to, for example, pandas is there's multiple ways of doing the same thing to get the same output, to get the same result. So you might see someone else doing it in a different way, but this is this is one of the good things about Spark is you get flexibility. You're not constrained to coding in one specific way. So our Spark session is ready. Let's just download the data. All good. I'm gonna open the data, and we'll use the same variables. So I'll store it in the DataFrame df spark.read. Again, there's multiple options you can choose. Just open CSV. I'm gonna choose option because I want to do some other things, but header is true. And what I also want to do is infer schema. Actually, let me show you one different way without infer schema, and I'll show you why it's useful to use it. And inside I want to just paste the path. So IPL option, this is the data, copy path, and let's run. Okay, so it's loaded. How you see data is using show, and inside show you can type how many rows you want to see. But by default, it's going to show you 20 rows, so we can see indexed from 0 to 19. So these are 20 rows. You can check the data. And let's look at the data type. So how you check the data type is by typing print schema, and you will see. So you see one problem here, right? That cost in crores and cost in US dollars. So these are two columns which should be float or double, but instead it's showing it as string because the data frame has not inferred what exactly does this column mean. So that is why it's useful to use infer schema, or the other way is actually define the schema yourself. But let's not get into it. Let's just see if infer schema works. Infer schema true, and I'm going to run it in the same variable, and instead of showing 20, let me just show 5 rows. Looks good. And so let's see if we run it again and if you see any difference, and you should. And now you see it's inferred it as double and floating points, which is perfect for us. One other possible way of doing it is using struct type, but okay, let me just copy paste it just for reference. And how you use it is you define a schema already, and you use struct type function, which you have to import from Spark. And then basically what you do is you select a column and you define it, if it's integer, if it's string type, if it's float type, and that's it. And the next step you actually do is, once you have a schema, is you choose another option, and in option you choose schema as, and then whichever variable that you have defined, schema, and it should work just as the same. So let's not do it because it's fine for now. But okay, I'm gonna leave this here. Okay, let's start exploring some data. The best, the most fun you have. So total number of rows and columns. How you use it is using a count function. Count function will show me total number of rows, that is 633. And if I want to actually check total number of columns, then what I can do is check length of these columns. So I use another function called length, and df dot columns, and this should give me so let me just type out print rows, and here I can gonna do the same, print columns, and close the parentheses. Okay, so we have 633 rows and 8 columns. Columns you can see, I think it's also counting as index. So 1, 2, 3, 4, 5, 6, 7, including index 8, and total rows are 633, which if you've seen the first part of the video, it's exactly the same. And next, you want to see what's the data type we already saw above, but let's type it again. So what you want to do is type print schema, and it will show you the entire schema. Sweet. Next up, we want to see unique values in the column base price. So the base price is the second column. So we want to see how many unique values does this column has, and also what are the unique values in these columns. So let's check it out. What you want to do is use select statement, and you will start observing that how PySpark, I mean, it's built on top of Spark, of course, but the API is very, very friendly and very similar to if you have experience using SQL, it's quite similar to SQL. So I'm gonna select the name of the column, and what I want to see is distinct values and collect them together, and let's see. So this column has values 20 lakh, 2 crore, draft pick 40, 1 crore. So just the values that's inside the column. And if you want to see the distribution of these columns, it requires you to do a group by, which is first I have to select the column, base price. Actually, I have to do a group by. Count and then show, and now you can see all the values inside these columns and by how many times or how often they are repeated. So 20 lakhs is repeated 344 and so forth. Let's go through them quickly so we can actually go through questions. I'm actually going to skip these and leave them for you to answer if you give it a try. But it's best, let's just get into the 5 questions we should answer. And not only that, we have to do some data transformations, which is usually very important step. And again, I'm gonna copy paste it just so we save time. What I want to do is rename the columns, and how you rename the columns in using PySpark is, so you choose this statement called with column renamed, and then it's quite straightforward. Old name, comma, and then new name, and that's it. And if you want to add like second column and third column, how you do it is just one more column after another. So you keep adding more columns, keep adding more columns. It usually starts to look quite ugly, so that's why what people do is you use a slash and move it to the next line, and another one. So you keep moving, and so it's more organized, and then you keep selecting the new columns in the old column. So just to save some time, I'm gonna copy paste here, but you can see, let me show the column again for reference. What I want to do is make everything non-capitalized, and if there's any spaces between, bring them together. So they're more coherent and easy to understand, especially these columns like cost. Too much stuff going on here, and that's not something you want in your column. So I'm renaming them to something more easier, and again, non-capitalized. But if you prefer capitalized, go for it. Whatever makes you happy. It's not a big deal. So I've saved the result in DataFrame 2. So let's check DataFrame 2. So you see, the columns are named different, base price, type, cost, easy to use. And one thing we did in the last exercise as well, we dropped a column, so you get to see how exactly do you drop a column. And I will save the results in new column. So df2.drop and cost USD. It's not gonna work. Let me see if it worked. Oh, it worked. Easy peasy. Because earlier I was using a column function, which is basically you import column and then you use column name, but apparently it's not required. So you see simple drop statement, and you select your column which you want to drop, and the cost USD is just missing in this one, which is perfect because it's not required. And data transformation is quite useful because you want to reduce the data that you're using into as little rows and columns as possible that you require, so you're not wasting space, and also transaction energy. So let's start answering the questions actually. I'm gonna expand, and the MySQL statement is still there, and there's a reason for it. I will show you why. So first question we wanted to answer was name top three batsmen who get paid the most. So you look at this column, and we want to find out the name of the players and who's getting the most pay. So again, let's begin. See how we would do it in Spark. Um, so first I want to do is select my data frame, which is now data frame 3, and select the name of the columns. So my column name are player, and the second column that I want to select is cost Indian rupees. And we can actually take a look at this data first before we start adding some filters. So we've selected the right columns, everything looks good. And next thing we want to do is add filters. And how you add filter is just type filter, and inside this filter I'm gonna again select the column, data frame, and the column is type, and in type I want to take a look at batter, and this should work. And after this we're gonna order. Oh, we change it to small capital, sorry. So type batter show, it should show us the results. Now next thing we only want to do is sort them out, and how you sort them out is, in fact, what you can also use in PySpark is, instead of filter, you can also use where statement if you're more familiar with SQL, of course, and you see both give you the same output. So it doesn't matter if you use filter, where statement, they both show you the same results. So that's one of the awesome things. So next thing I want to do is I want to order by, and I want to order by second column, which is Indian rupees, and ascending equals to second parameter is ascending equals to false. Hopefully I write this, spell that correctly, ASCE, and looks good. And I just want to see top three batsmen. So what did I type wrong? Oh yeah. Okay, perfect. So we're able to answer our first question, which is top three batsmen who get paid the most. So it's Rohit Sharma, Virat Kohli, and Kane Williamson. And now to get to this one, the reason why I didn't remove the MySQL here is from the previous exercise, because you can also use SQL statements inside Spark. And how you ideally do it is, first thing you need to do is actually create a temporary table, and I will show you how. So we use this statement, create or replace temporary view, and I'm going to name the table IPL. So what essentially this is doing is creating a separate temporary table called IPL, which we will use for running SQL. And you will see the results here. So I'm not going to change much here. Instead of MySQL, I'm just going to type Spark .sql, and at the end just type show, and it will produce the same output. You just Spark. Oh, sorry, I forgot to change the name here. And it should work. Perfect. So you can see inside Spark, you don't need to be really proficient with using the Python API. You can still use your SQL queries to get the results you want, and the benefit is you're using a distributed system, which essentially Spark is. So your queries run faster, and you should only use Spark when you're dealing with huge amount of data. And by huge, I mean it's over 20 gigabytes. You have, I don't know, 20, 30 million rows. So that is a good use case for using something like Spark. So let's go ahead, answer the second one. Top five bowlers who get paid the most. Um, Again, let me select my data frame, and then I want to select my columns, which is player, and the next one is cost Indian rupees. And instead of where, I'm going to use filter this time, and then again df3 type equal to bowler. Remember, in this one you have to use like a Python comparison operator, so that is why I'm using double equal to instead of single equal that you use in SQL. So remember that, because you might end up doing it. I mean, I did. And then order by cost Indian rupees. Sending equals to false, and show me top 5 values. Clear. Oh, sorry. So I mistyped here. This is the reason why. Great. So you see top 5 bowlers: Rashid, Deepak, Bumrah. Let's not get into the debate. But again, here we can simply transform the SQL one quite quickly. Just change the name. Spark.sql, and then just show statement. Same output. Actually, not. Oh, I did something different. So what you see is here quite unique. That what the second one did was um, actually. So you see, first four rows are the same, but the second one it's also sorted by name. So these two are kind of clashing on the same name. Sorry, same number, same amount, but it's decided to choose alphabetically in terms of equal. So same results, but kind of showing different outputs. Okay, the practice question is going to be left empty for you. You can download this notebook from Git, and you can practice it by yourself. Let's try and answer next three questions. Name three lowest paid wicket keepers. Sure. So let's select the players. I also want to select their. Do I want? Okay, no. Select their price. Filter df3.type equal to wicket keeper. Seems good. And I want to show you the results first, and then show you why we want to fix it. So the last part is just the same, so I'm going to copy paste from here, save some typing time. Clear filter DL3. Wicket keeper. Actually, we want it to be true because we want to get the lowest paid wicket keepers. Great. So we encountered that problem in the previous exercise also, that the column Indian rupees, if you send it from low to high, it's basically null values. So we want to filter these null values out. There's already a SQL written. So how we do it in PySpark is essentially you need to write another statement, and that will be, so we're using two filters instead of one. And let me copy paste this and I will show you how it looks. So the first filter is, of course, typing the batsman, and the second one is making sure that no null values consist here. So here I will be writing, first selecting the column, and PySpark actually has inbuilt this statement called not null, and that's pretty much it. So what it did was, first I filtered by my type, which was wicket keeper, and using ampersand I combined the second filter statement, which is select my data frame, select this column, and it should not be null, and it got rid of all the null values. So simple. All you need to do is actually just put this into practice, and it's not as complicated. All I need to select, just rename the column here, and again you see same results. It just alphabetically ordered here compared to this, which we can fix, but let's not do it. Question number 4. I feel like I'm getting out of energy, but let's go through them quickly because these are also not so difficult. So, what is the average pay for batsman, bowler, all-rounder, and wicket keeper? For that, what you want to do is a group by statement. So I'm gonna select my column data frame first. Sorry, group by. And what I want to do is select type, and then what I want to do is use an average function, and the average function will cost Indian rupees, and this is basically it. So looks kind of simple, and it's showing you this awesome awful result with so many values after decimal, but we can also fix it. So let me run the spark.sql. Okay, so if you look at the SQL statement, what you see is not only that I've used an average function, but I've also used round function, and I've used average price as an alias, and we will do all of these things here. So let's just first let me define alias. Alias here will be average price. And next I want to do is a round function. So for that we need to import functions as f, and instead of average I'm just gonna aggregate it, and then round dot mean, alias dot. Okay, let me double check. I'm using function. I'm rounding it. Average to the decimal point 2 alias, and I need to just close the function, and there you go. So what essentially I've done is, I've used imported functions, and just using it as a small as f, and then I'm using round function and then averaging round function with 2 decimal points. If you want to see the values up to 3 decimal points, you can definitely add 3, but 2 is more than enough in this case. And then the second half is using an alias to change the name for average price, because it looked ugly before that. So yeah, this is it. We've answered question number 4, and let's answer question number 5 and get it over with because I'm tired now. So yeah, let's go. List of retained players with team name and salary. Okay. So players which were retained, if you remember the data, actually if you remember the values here. So in the brace price we saw, yeah, so retained is one of those values in brace price. So these are the players which were retained by their team during the auction. So in the previous year, that is 2021, and in the same year 2020, this year 2022, they're playing for the same team. So let's begin. I want to select player, their 2021 team. It doesn't matter, you can choose 2022 team also. It will give you the same output. Indian rupees. Instead of filter, you use where df3 dot base price equal to retain equal. I constantly make this mistake. Retain, and I want to order by cost Indian rupees. Second parameter ascending equals to false dot show. And okay, what mistake did I make? Oh, DataFrame 3. That's the mistake I made. Okay, so you see the most expensive players: Ravindra Jadeja, Rohit Sharma, Pant, Kohli. I don't want to say anything. Sanju Samson. So these are the top. And let's check actually top 10. Who else was retained? Kane Williamson, MS Dhoni, Mayank Agarwal, Andre Russell, Jesus, Jasprit Bumrah. So, okay, let's not discuss cricket, and I'm gonna again finish it by transforming the last one, and I'm gonna change the name of the column, IPL, and sure. Cool. So thank you so much for watching the video. I'm gonna upload this on Git. So I will share the link in the video description, so you can download this and just practice it yourself. Hopefully you will have some fun. Thank you so much, and cheers.